Hello, everyone. Welcome to our post-processed Trimble Centerpoint RTX webinar today. The title of this webinar is Applanix PP-RTX, the powerful processing mode in Applanix POSPac. Thank you for joining our webinar. It seems we have a big audience today, and we really appreciate your interest. I'm happy to host this session today. My name is Nico Jäger, and I'm the product manager of POSPac, which is our post-processing software for GNSS inertial data. I'm joined by Michael from our support team, who will present together with me today and help with the Q&A session. In addition, we have Santia with us from our marketing team, who is helping us on setting up this session. So before we start, I wanted to raise your attention to our previous recorded webinars, which you can watch in our webinar center at applanix.com/webinar.htm anytime you want. Okay, some words about the webinar logistics today. The presentation will last approximately 25 minutes. So we're going through some slides that I present. Then we'll have a 10 minutes live demo by Michael, and an approximately 10 to 15 minutes Q&A session. The webinar will be recorded and shared with you. All attendees are muted. If you have any questions, they can be entered into the Q&A box at the bottom, and we will try to answer them during the Q&A session. If there are any remaining questions due to time restraints, we'll follow up with you separately, or if there are, let's say, questions that we cannot answer right away, no problem, we'll get back to you later on. So let's look at the agenda today. What is PP-RTX? That's what we will discuss. How does it work? We'll speak about the regions and the convergence, and what is convergence time in that context. We will look at the performance that we can expect from PP-RTX, the requirements, the different applications that we support, what are going to be the licenses that you need, what are the benefits, and then we'll get to a little summary before Michael starts with the live demo in POSPac. So what is PP-RTX? Trimble has a network of GNSS tracking stations worldwide. We speak about 100 plus, collecting data day and night. All data are processed in a control center, and via a smart algorithm, it creates a set of correction data for the rover. It corrects for standard GNSS error budget, such as for the satellite orbits, clock errors, atmospheric errors, which are typically the ionosphere and tropospheric errors, and make those corrections available in real time as well as in post-processing mode. So back in 2011, Trimble released the real-time Centerpoint RTX service, which relies on the generation of the precise orbit clock information and atmospheric delay models for the GNSS satellites. There are basically all satellite navigation systems supported here: GPS, Galileo, Baidu, GLONASS, QSAT, SS. PP-RTX is a cloud-based global GNSS correction service utilizing Trimble's RTX technology to provide centimeter-level post-processing positioning. So if we say PP-RTX, we always speak about post-processed PP-RTX and not real-time RTX. So the key message here is that when PP-RTX is being used, there is no base station needed for any processing. So at the end, PP-RTX is an alternative processing mode to single base, smart base, and multi-single base for GNSS inertial trajectory generation, which is the famous SBAT file. How does it work? So once the data have been imported into POSPac, the trajectory gets uploaded from POSPac into the cloud environment. The RTX cloud server then creates a set of RTX corrections, which are unique to the mission, to the rover data, and will transmit the corrections back to POSPac to post-process a centimeter accurate trajectory without the local base station. This is how it works for our Ion Fusion PP-RTX processing mode. Now, the new Ion Fusion Plus PP-RTX 2 processing mode does not require to upload the trajectory. It is available since POSPac version 9.0, but limited to uncrewed airborne business, such as UAV and drone business. In addition, if a correction download via internet connection is not available or unwanted due to some restrictions, RTX corrections can be logged over the air from the L-band satellite using the Trimble GNSS inertial hardware and post-processed directly in POSPac. Here are some other or additional specifics for Ion Fusion Plus PP-RTX 2. So the key differentiator for PP-RTX 2 are the new Baidu 3 generation observables, namely B1C and B2A. With those additional observations, we have an improved convergence time with PP-RTX 2 and a better accuracy in the global region. And that makes it suitable for short UAV flights, even outside of the fast region. The other thing I mentioned before, there's a direct download of the correction data. No upload of the trajectory is required when using PP-RTX 2. In addition, we have the over-the-air option to log the RTX corrections, which can then be used in post-processing mode. However, a PP-RTX license is required. We'll speak about the license a little later. Users can also restrict the RTX correction download in POSPac and force the software to use the over-the-air corrections only if there are any restrictions for uploading geodata, for instance. As I said before, currently this is limited to UAV applications, means in terms of the hardware, it's APX boards, AP+18, and AP+20 boards. We're also expecting more signals to come into the game, such as the B3 from Baidu and E6 in the future that are hopefully even improving PP-RTX 2 processing more. We have different regions, and we'll speak about this now and the convergence about this. So the Trimble Centerpoint RTX services are split into two regions. We've got a fast region, which is which covers Central Europe and North America, and we have the global region, which covers basically the rest of the world. The global region corrections are based on a global ionospheric model, while the fast region uses a denser network of reference stations to compute a regional ionospheric model for atmospheric corrections. But all in all, PP-RTX is a service that's covered globally, so you have a worldwide coverage and you can use PP-RTX wherever you are. So what's convergence time in this context? The convergence time is the amount of time it takes to reach its full position accuracy. Any convergence effects are removed by combining the forward and reverse solution. So I repeat, since POSPac PP-RTX solution is processed in the forward and reverse directions and then combined, all potential convergence effects are removed. It's important to understand that the convergence time drives the minimum mission length in post-processing and is not the time required to reach a certain accuracy specification in post-processing. So here we have the convergence time and the resulting minimum rover data length for post-processing purposes. If you are in the fast region and you process in Ion Fusion PP-RTX or Ion Fusion plus PP-RTX2, the convergence time is around 1 to 2 minutes. And that means your minimum rover data length is about 10 minutes. If you are in a global region and you process Ion Fusion PP-RTX, so not the PP-RTX2, then the convergence time is about 15 to 20 minutes. And that means your rover data length needs to be 20 to 25 minutes. However, if you are in a global region and you use our new processing mode, Ion Fusion plus PP-RTX2, with the Baidu 3 satellite generation, the convergence time is improved and goes below 3 minutes. And that means your minimum rover data length is also 10 minutes, like in the fast region. So Ion Fusion plus PP-RTX2 thus allows higher accuracy, GNSS inertial processing for short uncrewed flights worldwide without using a dedicated base station. Here's an example of one data set in the global region that illustrates the convergence time improvement. So on the left side, you can see a graph of the error for the horizontal error and the vertical error. So this is basically the comparison between the Ion Fusion PP-RTX processing and the Ion Fusion plus PP-RTX2 processing. The blue line presents PP-RTX standard processing. The orange line presents PP-RTX2 processing. You can see that we have a significant convergence time improvement. It basically goes down from 8 minutes to 2 minutes in the global region. So that means it makes the new PP-RTX2 processing mode suitable, again, for short, uncrewed airborne missions in both the global region and the fast region. Let's speak about the applications. They're all listed here with a little traffic light. So the first one is the crewed airborne application with typically 1 to 3 hours data. It's ideal for PP-RTX. There's a high flexibility in regions with no or sparse GNSS-based network, which is traditionally used for single base or smart base processing. But surely, also in regions with good GNSS-based coverage, it is a powerful alternative processing mode. Of course, uncrewed airborne, as said before, as we learned, it is attractive for worldwide operation using our new Ion Fusion plus PP-RTX2 processing mode. For the marine business, that's specifically very attractive for offshore operations where you typically have no base stations around, but it's also used for nearshore application, such as port surveys, etc. For the land and autonomy business line, I switched the traffic light on yellow because it works good in open sky, but it's not tuned for applications in GNSS critical areas for now, such as urban or canyon surveys. However, in open sky, such as in rural areas, open mining pits, or for highway mapping, it is definitely an option for the processing. It may also be useful for application where you don't hunt for the last centimeter accuracy. So what is the performance that we can expect? Whether you use Ion Fusion PP-RTX standard processing or the new Ion Fusion plus PP-RTX2 processing, doesn't matter. The horizontal RMS that we specify is below 3 centimeter, and the vertical RMS is below 6 centimeter. So here's an example, basically a comparison of the PP-RTX versus PP-RTX2 processing in the global regions. What you can see here is the RMS of 66 UAV data sets from the global regions, where we compared, again, both processing modes with each other, but also looked at the reference of a nearby single base station. And in each of those cases, there was a base station present, a good and healthy base stations within a radius of 10 kilometers. So when we compare PP-RTX against single base in the standard ion fusion PP-RTX processing in the global region, we saw north and east RMS of 4.2 centimeters, and the down error was a bit over 9 centimeters. With PP-RTX2 compared to single base processing, we lowered the RMS, the horizontal RMS, down to 1 centimeter, north about 1 centimeter, east as well. And for the down component, for the Z component, it was about 5.5 centimeters. So you can see how significant the performance has improved between those processing modes, given the fact that you also have those additional observables from Baidu. So this makes the new PP-RTX2 processing mode suitable again for short uncrewed airborne missions in both the global region and the fast region. Now let's go through some examples of the different business lines or the different applications. So let's start with an example of an uncrewed airborne flight where the base station is closer than 10 kilometers away. And what we did here is we compared the PP-RTX2 processing versus single base processing. On the lower left side, you can see the graph in the northeast down components, plotting the error over GPS time. And on the right side, lower right side corner, you can see this summarized in a table. So we can derive, obviously, the RMS value when we compare both processing modes over the GPS time. And we can see that the northeast error is about 1 centimeter and the down position error is about 2 centimeter. And that example even outperforms our PP-RTX specifications that I mentioned before. Here another example for a crewed airborne flight where the base station is within 20-kilometer range, and we compared with ion fusion PP-RTX standard processing. That data set is from Israel here. Same thing. On the left side, you can see northeast and down plotted RMS or difference over GPS time. And on the right side, we can see the northeast down RMS, which is 1 centimeter horizontally and 4 centimeter vertically. Here an example for a marine port survey where RTCM corrections were available and the base station was in a radius of below 10 kilometers. Same thing here. We compare ion fusion PP-RTX processing against single base processing, and we have an RMS value which is even below 1 centimeter horizontally and vertically below 4 centimeters. And here another marine example for offshore survey. The trajectory in this case is 140 kilometers away from the coastline. And traditionally, you wouldn't expect to get any base station over the sea here being offshore. So PP-RTX is the best alternative for post-processing purposes. Same here, we'll plot it over time, northeast down, and the summary is on the right side. The RMS value horizontally is about 2 centimeters max, and for a Z component, it's below 4 centimeters. So what are the requirements to use PP-RTX? So first of all, you will need to have a valid PP-RTX subscription accompanied by a standard GNS inertial license, typically nowadays a term license. You need to have a minimum of 10 to 15 minutes rover data in the fast region or in the global region with Baidu 3 signals using the ion fusion plus PP-RTX2 for UAV. In all other scenarios, you will need to have 20 to 25 minutes rover data. The rover must be using a calibrated GNSS antenna, and that antenna needs to be selected in POSPac and needs to be an associated model here. You need to have clean GNSS observables throughout the entire mission and internet connection. However, that internet connection is not required for Ion Fusion Plus PP-RTX2 processing if center point RTX corrections have been logged in real time. There are some additional PP-RTX2 requirements. As we said before, this is specifically currently for uncrewed airborne data collected by the following hardware, which is APX15, APX18, 20, and the AP plus 18 and AP plus 20. And for data in the global region, you've got to log the BeiDou3 satellite generation, specifically the signals B1C and B2A. And here on the right side is an example where the suggestion is on what satellites or what signals should be really selected for logging purposes. Of course, we always recommend to run the latest firmware, but the minimum firmware that you need is version 8.2 to allow for the B1C and B2A observable tracking. So what are the licenses that you need? I mentioned before, you need to have a subscription license, and there is a subscription available for POSPac MMS, which is our big package, and that's basically supporting the crewed airborne business, the uncrewed airborne BVLOS business. So BVLOS are long endurance flights. The abbreviation stands for Beyond Visual Line of Sight. Then for marine applications and for land applications, as I said, more for the open sky scenarios. We have another subscription which is tailored for really UAV purposes, and that's for POSPac UAV, where we support dynamic data length of about 30 minutes in PP-RTX mode. And we have a POSPac Go PP-RTX subscription that is for marine purposes, and it's basically a one-button function that allows you to create a post-process solution very quickly after data acquisition. The subscription period can vary between 6 and 60 months, and typically increments annually. Yeah, the longer you purchase the subscription, the more discount sits on it typically. So what are the benefits of PP-RTX? So the general benefits here, of course, the main benefit here is really there is no base station that you need for processing, for post-processing. And that means you eliminate the ground-based setup, for instance. You would eliminate the need to download base stations from various sources, which is always a headache if you try to get base stations from various sources or even from different countries. You eliminate the need to sign up on various GNSS service providers in different countries, especially if you operate internationally. You can retrieve the correction data over the air or within minutes via internet. We do have a faster convergence time with BeiDou3 and PP-RTX2 in the global region, and not only a faster convergence time, but also a better performance. There is no trajectory upload anymore when using PP-RTX2. It's only the download of the correction data from the server. And the whole thing obviously improves your efficiency and productivity. And you can consider PP-RTX as a single button function. We are approaching RTK accuracy, as we said before, 3 centimeter horizontally, 6 centimeter vertically. There are no baseline restrictions here. That's another headache typically if you do single base processing or even smart base processing or multi-single base processing. In any case, you kind of need to think about your baseline length and whether this is all okay in order to cancel out all the GNSS errors. But as soon as you use PP-RTX, you even don't need to think about that anymore. And we have a worldwide coverage. So wherever you are in PP-RTX mode, you can use it. You can process your rover data. So one last benefit I wanted to bring your attention to is the batch command line executable that triggers automated processing. You basically can define a batch template, which is an XML file, to be used for your standard operations. So that can be really a standard fixed template, and the only variable is going to be the input files, which are the rover files, which are the raw files that you use. The rest is basically the same. So this is one execution function. It does increase the productivity, efficiency, and reduce operational mistakes, even because you can also define settings in the batch, such as the lever arm or IMU rotations, things that an operator can wrongly type in or overwrite in POSPac in the GUI mode, and then obviously introduce errors. If you switch to the batch command line, you can minimize the risk of any errors. And integrators can use also this one to implement in their own software. And at the end, there is also a route to go to POSPac Cloud. So the batch command line or the definition of the batch file, again, which is an XML file, is basically a prerequisite before you can onboard on POSPac Cloud or to POSPac Cloud. Well, that's a different story. Shouldn't be touched too much today. So summary. PP-RTX is a worldwide cloud service for various applications, replacing the need for base stations, while maintaining centimeter position accuracy a few minutes after mission completion. So that will aid to your efficiency and productivity. There is no need to wait for any other GNSS service data. PP-RTX is basically available instantaneously. Okay, so this is where I end my presentation for now, and I will hand over to Michael, who will demo PP-RTX in POSPac.
Yes, thanks, Nico. Hello, everyone from my side. I hope you can see my screen in a minute, like now. And I will go to show you some steps how easy it is to process data with PP-RTX. And at the first, you will see my screen. This is POSPac 9.0. And now I already saved the project and will import the data now, the raw data from the rover. So now POSPac is going to load ephemeridis information and Earth rotation parameters. This will take a few seconds. Okay, download has finished. Now I have to set up the antenna time, which is important for the PP-RTX performance, like Nico was mentioning. So here I will choose the AV14 antenna, and we will see our trajectory. For the display, I will not show the events here. And the next step is to edit the settings for our project. Now I'm going to show you the settings window, and I will input the reference to primary GNSS lever arms. And I will set the standard deviation to 0.01 meters. And the IMU rotation angles are already visible here. So you will get the parameters or the values by measuring it, or in case you have a CAD model, this would be the best option to have the precise data. I'm going to save it. And now we're going to start the QC. Here I'm using the Infusion Plus PP-RTX2 algorithm because this data set is from the global region. At first, I will start the QC processor. And this will need some time, some seconds to load the corrections. So the specialty, as Nico was mentioning it, is that only the corrections are being downloaded from the server and no data is being uploaded, which is important for some countries. So, and we see here is progress visible.
Just to add, if I may, this is not only the downloading, this is already the QC process. So the observables are checked currently, and in the back end, there is the GNSS only processing happening. So it does merge the GNSS rover data with the PP-RTX to correction data, and will give us the statistics about it in a couple of seconds.
It seems today we have to be extra patient. But finally we get the results. Okay, here are the QC statistics, and we have in the data set between 11 and 28 satellites. I will go to specified later on and say okay for this time. And now I can run the forward and backward processing already. And yeah. This went quite faster than the QC. The aspect is ready, and I will save the data. And now I'm going to show you some plots of the results in the display plots. And first we want to take a look at the primary signal, like Nico was mentioning it. We are going to check the Baidu phases, that is Baidu 1C and Baidu B2A, which is the specialty of PP-RTX2. And you see here, both phases are listed over the mission interval that is visible. And this is for better accuracy, especially for the UAV flights. So we go to the QC.
Michael, a second. Are you showing the display plots right now?
So this is B1C and B2A is here.
I'm not seeing it. Sorry, maybe others. But
all right. Okay. Maybe I'll have to share my screen a little bit different. Just a minute. All right. Maybe I have to share the whole screen.
Yeah, please. I think that was the issue.
Yeah. This is the display plot. Do you see it now? This might be the
now.
This is the
Yeah,
display
maybe
plot. Sorry.
You start from scratch from there.
Yeah, no problem. So this is the Baidu 1B, 1C phase and the B2A phase that are visible for the whole interval during the mission. So I will proceed to the PP-RTX QC and the number of satellites. And you see here the number of the total number of satellites, as I said, between 11 and 28. And we have here GPS satellites, and the Baidu satellites are here in purple color, and even we have one QZSS satellite. And the most important thing is for the Baidu phase that we can track these satellites, and all the signals are being processed with the Infusion Plus engine. I will now show you some pictures from the results from the solution status, the processing mode, and you see here over the whole interval, the processing mode is changing here at the beginning. So here we have the float solution, and for the first like 2 or 3 minutes, and then for the rest of the interval we have a fixed solution, which is very important. And yeah, so now I'm going to show you the performance metrics from the aspect solution. Here we have the north, east, and down position, and we can see here, of course, the down position is a little bit higher than the north and east position. And we see that these curves are quite flat over the whole mission interval, okay, besides the edges. And there's no convergence visible. That means from the start to the end, we have more or less continuous RMS error visible. And yeah, we are meeting here the specifications, and this is I wanted to show you. If you have questions, please write down your questions in the Q&A session. And now we're going to try to find the answers for your questions.
Yeah, thank you very much, Michael. So I'm going back to share my presentation here. So yes, as Michael said, let's go through the Q&A session. As I said before, use the Q&A icon at the bottom to write your questions. We'll try to answer them. So Michael, if you can open up the Q&A box and maybe start with the questions, and
yes, of
I'll
course.
try to answer.
Of course. So the first question is PP-RTX outputs to ITRF 2020. How easy is it to export on a different ITRF? And what internal transformations would be applied?
Yeah, that's the same as always. Whatever the ITRF is that we use for PP-RTX, and I believe ITRF 2020 is the latest one and is correct. It does not really matter as long as you tell POSPac what the target datum is you want to export to. And we support various datum definitions like the ITRF 2014, ITRF 2000. We support the American datum, the European ones, etc., etc. So at the end, when you export your solution, that's important what you click on, what you activate there, and then you will get what you need. Next one.
All right. So the next one is, if one uses PP-RTX already, but would like to try PP-RTX 2, what would be needed? A subscription upgrade?
No, it's the same subscription. We don't differentiate. If you have a valid PP-RTX subscription, you can use IMfusion PP-RTX or IMfusion Plus PP-RTX 2. Again, I want to emphasize that IMfusion Plus PP-RTX 2 is currently only for UAV or uncrewed airborne missions. Next one.
Okay. Yeah, the next question is, does this only apply to applications that utilize an IMU?
Our POSPac software is in GNSS inertial processing software, and that means it comes with the GNSS and the IMU from Trimble, and that's why PP-RTX is always using GNSS and inertial measurement unit data.
All right. So there's another question, would I have to upgrade the PP-RTX license to PP-RTX 2? I think you already answered this,
That's
right?
Yes.
Okay. The next one is, what is the difference between PP-RTX Go servers with that of the PP-RTX MMS for marine users?
PP-RTX Go is a separate service that you can, where you don't need to install even POSPac. So it's a separate executable that can sit right on your vessel, and you can just press just a single button icon and you get something processed. So there's a big difference. You wouldn't even see when you load the trajectory. There is no GUI mode or anything like that.
Okay. So we have another question here regarding the length of a survey. For longer UAV flights with PP-RTX for more than 30 minutes, should POSPac MMS be used instead of POSPac UAV?
That's kind of correct if your UAV flights or the dynamic part of the trajectory, so the time when you're really in a dynamic mode, so the non-zero velocity data is over 30 minutes, then you better use POSPac MMS with the PP-RTX subscription from there. We have this tailored PP-RTX for UAV subscription, which runs in POSPac UAV, and there is a limitation of 30 minutes on it right now. That's true, but there is also different pricing for it. That's the big benefit if you're operating standard short UAV flights.
Okay, yeah, we get many questions here. The next one is, can the system also be used in the Arctic and Antarctic regions?
As we said, PP-RTX itself is covered worldwide. That's different than real-time RTX. Okay, so in real-time RTX, there are limitations, but for PP-RTX, post-processed RTX, this service is covered worldwide. And yes, Arctic and Antarctic is part of it.
So maybe here is another question regarding to the region. In what types of geographic areas will PP-RTX not work well?
There are no of those geographic areas. It's all the same. The difference that we have right now, as it said in the presentation, is we have the fast region and we have the global region. In the fast region, you have a very sophisticated ionospheric model that helps you to get a faster convergence. So that means your mission time length can be shorter. Versus in the global region, we have, let's say, a standard ionospheric error model. So convergence may take a little longer if you're not having the latest Baidu satellite and the Ion Fusion Plus engine. But in general, there are no limitations, and there is no performance loss. So the performance that we state is really worldwide. And again, 3 centimeter horizontal error and 6 centimeter vertical error is what we expect.
All right. The next question is the QC step unique for PP-RTX2? For plain old PP-RTX, it's just GNSS inertial processor and then PP-RTX processing. I guess this is the question regarding the QC button I showed during the live demo, right?
I think the QC button itself is always a prerequisite for any type of processing, whether it's PP-RTX, PP-RTX2, single base, whatever. It creates always the GNSS only solution. So before the solution gets merged with the IMU data, and this is a step that's always needed, and it has not changed.
Okay, so the next question is, did you test performance in offshore areas or even in mid-ocean by POSMV on vessel? And what is to expect?
We're expecting the same as I have presented today. So whether you're 140 kilometers away from the coastline, and as in my example, or you are further mid-ocean, it is covered, it is working, and we're expecting no different results.
All right. The next question is, PP-RTX is using broadcast ephemeris, right? Would precise ephemeris increase accuracy? If yes, in which level?
Well, we use all the precise information in the backend. As I said, that's the whole thing about PP-RTX. We have a very good understanding of the ephemeris, good understanding of the clock errors, and of course of the ionosphere and troposphere. That's the whole point of PP-RTX. So we are not just using broadcasted ephemeris, but this is something that users don't need to worry about in POSPac. It's all automated. It's all automated, right?
Okay. The next question is EGM96 okay to use universally while working in marine environment?
I believe EGM96 is a GeoEat model. I'm not so sure right now because this question is a little vague, but EGM 96 GeoEat model is covered worldwide. I'm not so sure whether that is useful to use in the marine environment. I think we'd need to ask our marine CS support guys for more information here.
Okay, thank you. The next question, will PP-RTX and Infusion Plus be developed for the use with crewed airborne missions in future?
Can you repeat, please?
Yes, of course. Will PP-RTX2 and Infusion Plus be developed for the use of with crewed airborne missions in future?
Yeah, that's always risky to answer those questions, I think. But of course, we're trying to make IMfusion Plus PP-RTX available for other business lines in the future, and I guess that's not a big secret. So we are working on including other business lines for sure with PP-RTX too.
Okay, so I think these are mostly the questions from the chat. Maybe we can wait a few seconds when there are more questions are coming in from the audience.
Yeah, so I think one of the questions here that I've seen before, and I answered quickly in the Q&A box, is whether the presentation or recording is available. I think some of you guys may have missed the start of the session. Of course, you'll get an email with the link of the recorded session today. Okay, are there any more questions, Michael?
No, I don't see any more
Okay,
questions.
if there's anything else that we have missed, I think I'm seeing a very long one right now, but as I said, due to some time restraints, let's get back to those longer questions separately, and let's conclude from here. So thank you very much for your time today. As said, you will receive an email with the recording today. And one last note, if a trial license for you guys is of any interest, you can send an email to our support department, which is techsupport@applanix.com. Okay, thank you very much, and bye-bye.